I think because I want to keep track, you know. Oops, what happened? Come back. All right. So, paper. I need lots of paper. Now we're gonna need a calculator. We're gonna need all right. Okay.
It seems like the one you did today where like you're walking this way and then they do a U-turn and they're going the other way.
Yes.
So it says...
Just give me one more second because I'm gonna, it's easier for me. I'm just gonna log into WebAssign so I could read the problem.
Yeah.
Hello. WebAssign, that's, where's my WebAssign? This is my WebAssign. That's a homework 1, part 1, correct?
Yes.
And the problem number 3. It's something left, someone walked left and right, yeah?
Yeah, it says they walked west and then turned around and then walked east.
Mm-hmm.
And I thought I knew how to
Did you read the notes to this?
Yes.
So let's see, I think problem 3 is, so it says different ways to approach the problem mathematically, but physics is based on definitions. Okay. So can I see your picture, please?
My picture?
Yeah.
Well, I did just like going this way and this way.
Well, first thing, you don't have a picture. If you don't have a picture, how can we?
This is they walked, well, I have my west and east mixed up, but they walked this way and then turned around and walked that way. I put an arrow. So they're walking this way at 2.53 meters per second.
You see? Everyone should be able to look at a picture and understand what's happening without asking you to say any single word. So your picture doesn't have information, so you need to draw a good picture. And I would always advise just take a piece of paper, because it's not your notebook, so you're not afraid to mess it up, and draw a picture. Just move over here. Yes. And you, sir, do you have questions?
I'm doing the problem 3 as well.
So in that case, just move over here.
Okay.
And you together should draw a picture which represents what's happening as clear as possible. I didn't finish the problem today. The class ended, but that's very similar. Yeah, but still, the first step is a picture. So please draw a picture. You have different numbers, but you have exactly the same situation. And numbers don't matter, right? So you can draw your picture. So what happened first?
They walked west and
West.
this length, I'm not sure how to represent that, is...
So exactly, you need to figure out how do you want to represent it. It is just not a number, right? You have to invent some label, variable, which you would use for that.
Yeah, so they walked this much, this length.
Yeah, how do you call it? What label?
West. What?
A letter, variable, label. you want to use for this number, because you're going to do some algebra, you're going to do equations, and algebra equations require labels, variables, letters. So you have to assign a letter to this number. You can pick
Well,
any
just-
letter,
The length, so maybe L.
write
That
it
is-
down. L,
Yeah, and this is just the speed, so little v.
okay, all right.
And they turned around.
And before we go further, so when motion is happening, we usually relate three different variables: length, speed, or else.
Length, speed, and velocity.
Well, speed and velocity are very similar to each other. So they both characterize how fast length or position changes when time runs, right? So in addition to length or distance or coordinate, that's one group. Speed, velocity, that's another group. What else is important?
Acceleration, maybe?
That's
Okay, I don't know.
too far, yeah. And you used it in your notebook because I saw it. Another
The
variable.
average?
Well, the average velocity,
Yeah.
for example, equals what, according to the definition, which we
the-
learned today.
Like, final minus initial,
Net displacement over time.
yeah.
So you need to be able to say exact definition in words. Displacement over time. Velocity equals displacement over time. So if I ask you again, if we need to describe this motion in addition to velocity and distance, where else should we use?
Time?
Time.
Okay.
Well, if velocity equals distance over time, so there are three variables which must be used to describe this action: distance, time, velocity. So I see you have a letter for distance and a number. This, I'm not sure, might be speed or velocity. I have to check it, but still I see the number. And there is another variable, time, which is supposed to be assigned to this. So please choose a number for time it took to travel from here to here. Choose a letter. Choose a letter. Sorry. T. It's your choice. T. All right. We are done with this part of the motion. Next part of the motion. Do you have a question?
Yeah, on the website account.
Which problem?
I used an old account,
No.
so when I didn't make a new one. So.
Your question is about account or is about the homework problem?
No, just the account, like not a homework problem.
For now, just forget about it because I haven't had time to check what's happening on the website, who has what. So, do you see homework assignments? Can you do them?
Yep.
That's it. You're all set for now.
Okay. I'm not gonna like lose points like it said on the syllabus.
It says might.
I'll just keep doing it.
So for now, just keep doing what you've been doing, and eventually I will find out what's happening inside the website. As long as you can see assignments, you're all set. Okay? Okay, good. So now it travels east, right? Do you know how
Yeah,
Much?
0.43 meters per second for the speed. It
Okay,
doesn't say.
doesn't say what?
It doesn't say like how far you walk east, just the speed.
Okay, so you don't know the number, but that doesn't mean that distance doesn't exist. So it exists, and if it exists, you can use a certain label, variable, letter to describe the existence of it. So what?
Use L.
L again? Oh, L2, okay,
L1.
perfect. And it took a certain amount of time. Perfect.
T1, T2.
Yeah, but I think you know something else, right?
Yep, the average velocity. But it's only for west, so 1.25 meters per second.
I think you know three different velocities, right? You walk 6.44 kilometers at a given speed. then you turn around and you walk at a given, and from your starting point to your destination, the magnitude of your average velocity. Okay. All right. So, yeah, I didn't have time for that today. That's the first part of the whole motion. That's the second part of the whole motion, but that's the whole motion here, correct?
Mm-hmm. So is that saying the average velocity for the whole trip is 1.25?
Yes.
Okay. Why does it say due west in parentheses?
Isn't that like where it starts from?
Because velocity points somewhere. It points in the same direction the displacement points. So if you start here and you walk to the left, you make a U-turn and you walk to the right, this is your initial location. This is your final location for the whole trip, right? Mm-hmm. So this is what we call start, this is what we call finish. So how would you draw an arrow here which represents your actual net displacement or total displacement?
From here to... Oh, is this where the arrow ends? So here to here.
Oh, this is just the direction. This is how long it will. So your total displacement for the whole trip, well, starts here, right, and ends where? Here. So you got to draw an arrow. That, well, again, I like using a letter S, but I just remember that this S represents word start, and this is the displacement. So this is your displacement. That's what it means. That essentially, after moving left and right, you'll end it up to the left to your initial position. And how did you call it? I don't know. I would call it S1. I would call it S2. Those are distances traveled. And I would call it V1, and I would call it V2. And this is V total. Now, the tricky part is that when you use equations, you have to keep track of, what is represented by this letter. Is it the speed or velocity? Because it makes a difference. Is it distance or displacement? Because it makes a difference. And actually, there is also time 1, time 2. There is total time total. Okay? So, this number, let's use your number, V1, 2.53 meters per second. Is it an average speed or an average displacement, an average speed or an average velocity for the first part of the trip?
Speed.
Does it say?
Yeah, it says speed.
Okay, so to be safe, this is how I want to indicate it. This is the magnitude of that velocity. Now, V2. Do you know it? Your number is 0.43
Yeah,
meters per second. What does it say? Is it speed or velocity?
speed.
All right. And we know total, which is 1.25 meters per second. So those are all magnitudes of those actual velocities. And I've mentioned it quickly today. Velocity for one-dimensional motion can be positive or negative because it points one way or another way. So speed cannot be negative because it's magnitude. All right. Now, that's all we know, right?
Yeah.
So next step, we have to start writing something which we can use to connect all these quantities. So what would you recommend to use?
was getting tripped up because we weren't given like time.
No. I saw you had an equation. Can I see it one more time? What equation did you use? Here, v equals x2 minus x1 over delta t.
I was gonna try and use that because they gave us like the average velocity, but without
all
the
right.
time, I got kind of confused.
So we have learned today two definitions. One definition for, well, let's call it average velocity, and for one-dimensional motion is this. Second definition is average speed, and that's distance over time. And that's all we know. So if we don't know anything else, that means we have to use something, this or that.
Maybe like find average speed. Well, we don't. Just kidding, because we don't know the other. Just kidding. I was gonna say maybe we could use this to.
Why
find
do you
delta
care
T.
what you know or what you don't know? Don't you think physics doesn't depend on what you know?
But you have to use what you know to find what you don't know.
So you're saying, I don't know time, and because of that, I cannot solve the problem.
No, I was saying I didn't know how to without the time. What I was just thinking is maybe we could like find average speed, but we don't. We only know the distance for when we're going west. Because I was going to say maybe if we find delta t, then we could use delta t to find what x2 would be.
You see, that's exactly what I said today. Don't think. You're trying to think out loud, and it doesn't go. It doesn't. I
was reading this lab, and the first part really confuses me. Are they really going to measure the distance between the two hallways, like this part?
yes.
And what is the measurement tape that they mentioned? I didn't see that in the lab.
So you weren't paying attention.
Yesterday?
Yes.
I don't.
There is the
remember.
box.
Huh? Oh, there's a box. Okay.
Who are you working with? Who's second tier?
Jack. Pinchon Kid.
Yeah, I know Jack, and he did this lab.
Oh, he
so,
did. Okay.
So you have to talk to him. He knows everything.
Okay, good.
And you should have asked this question before the lab, not during the lab.
I know. This is not during the lab yet. I mean,
Okay.
he's going to be here.
That's fair. Okay. But everything is in the lab room by the central table, measuring tape in the box. And I sent yesterday notes to this lab.
Oh, yeah.
Check it, because that tells you everything what
Okay.
should be done. So first, nature doesn't care about us. It doesn't care if you think about it or not, which means this problem cannot depend on do you know some certain numbers or not, which means you just have to act like you know everything you need and see what's going to happen. So if you knew that time which confuses you, what would you do? How would you act? What would you write? So if the rule is very simple, imagine that you know that number, yeah, and just go ahead. But when you write an equation which you want to use, instead of the number, just write a letter which you imagine you know. And that's it. Every time when you know a number, you can use that number. But if you don't know a number, imagine that you do and proceed. That's it.
Okay. So
All right? That's a general rule. Because every problem, well, on the web design, has a solution. So it's not a tricky problem. It's a straightforward problem which doesn't require any kind of, extra information or extra reasoning. It's a very straightforward problem. You just have to overcome that barrier. I don't know that number. Mm-hmm. Well, maybe you don't need to know that number because you didn't solve the problem yet.
yeah.
So if you knew this number, what would you do?
Well, if I knew like the change in time, so it'd be.
So please let me ask you. So you write an equation for the whole trip, right?
Yes,
For the whole trip. Well, that's the magnitude of average velocity, and the magnitude of average velocity should be equal to
change in displacement.
All right. So this is supposed to be in the numerator, and the denominator is supposed to be total time.
Mm-hmm.
So actually, I didn't add all your numbers. So we know this, we know this, we know this. This S1, this distance is equal to 6.44. That's for everyone.
Yeah, I put it in meters.
Okay, and yeah, we gotta need so 6,004. All right, and what else? That's it. Yeah.
Mm-hmm.
Okay. Well, actually, 2.53 distance, speed, time. I think here you can actually calculate time very quickly for this part of the trip, because for this part of the trip, the magnitude of average velocity equals 2.53. For this part of the trip, distance traveled equals 6440, and for this part of the trip, time, well, is related to these variables by the equation of your choice, right?
Yes.
So
Is this?
there is something you can do right now, and if you can do it, just do it. It makes things easier.
Is that how you find seconds?
Well, you have to pick an equation. Which equation do you want to use?
I wanted to use this one.
All right, but
Then you just
for a different number, you have to use this equation, but for the first part of the trip, not for the whole trip.
Okay. So.
So the same equation can be used 3 times. This equation you can use for the first part of the trip. This equation again you can use for the second part of the trip, and this equation again you can use for the whole trip. It's the same equation.
Okay.
So,
I know the speed.
yes.
Yes.
Well, that's not that's magnitude of average,
Yeah.
whatever.
Well, because if we're just going to do it for the first part,
Yes.
it would be 2.53
Okay.
equals 6,440
Okay.
meters per second.
You don't have to write all the units all the time. Just keep in mind that you use International System of Units, and you will be all set.
And then it'll just be over delta t. And then calculator isn't good.
No,
No?
not yet.
Oh.
First, we have to solve it. You need to write an equation which you want to use, then you have to solve it for the variable you're looking for. Delta t equals now you can take a calculator and finish this. Now you're ready. You weren't ready yet. So this part was easy. Now you have to pretend that you know everything for the second part and write an equation which you would use to relate those variables. So the hardest part for you now is to invent the algebraical, mathematical way how you would describe this number related to this number and that number. Part 1 is done. Now it's time of part 2. You know that when it was traveling from here to here, the average velocity was, well, point something. And you pretend that you know that it took this time, it traveled this distance, and you can write an equation. So you You have to write an equation. Yes. You cannot use delta t.
Okay.
Well, is this
Well, delta t.
2,000? No.
No, different.
Okay.
Delta t.
Do you know L2?
No,
Do you know delta 2?
no.
You're done with this part.
Yeah.
You cannot do anything else. So now you have to move to the next option. What's left? We did everything we could to describe part 1. We did everything we could to describe part 2. What's left?
Part 3.
What is
So
part
the-
3?
That, like, average velocity.
The whole thing, the whole trip, exactly. So now you have to, again, use the same equation and write it, but for the whole trip, you know that this will be equal to a given number. Now, well, you didn't finish. You have nothing in an numerator.
Yes.
See? This is the magnitude of the displacement for the whole trip. This was equal to 6440, and this was equal to S2 or L2. Okay, these are the steps in the right direction, but it needs some fixing. Let's take a look. So here, this is 6440, this is L2, this is, how do you call it, well, S. Please write an equation which relates S, 6440, and L2. That is correct, but I wouldn't do it that way. For me, it's much easier, right, that this plus this will be equal to 6440. And in your head, you already solved it for S, X equals 6440 minus L2, and you wrote it
The opposite.
the opposite.
Should I switch the times as well?
Now, let's talk about time. It took, how much time did it take to travel to the left?
I got
2545.45 seconds. Okay. And it took seconds. It took T2 or delta T2 to travel here. So total, it will be equal to, how do we calculate the total time?
It would be this plus this.
Exactly. So when you say it, it's right. You just have to write it right. Yes.
So did you get the email yesterday from me? Because I
don't know.
didn't. Sorry.
I didn't have time yet to check yesterday's emails.
Yeah, yesterday you sent out that email at 2 p.m. and then I didn't check the email until 11 at night. So I didn't know that the office hour changed. But then I saw the new office hour chart. So
Yeah.
there's a slot still available at Friday 2:30 to 5:30. So I sent out email because any
Look,
other
if
slots-
it's about Friday, we can talk it on the meeting on Friday.
Oh.
If you're fine with today, tomorrow, so
Yeah.
we can meet on Friday and finalize everything on Friday.
Okay.
That's easier.
Okay, sure.
Okay, so what do we have here? Now, if we combine these together, the magnitude of average 1.25 is equal to this minus this distance, Well, this is basically technically magnitude of that displacement, yeah, but it's also distance from here to here, right? Equals to T2 plus your number. Okay. So this L2 and this L2 is the same L2. This T2 and
It was delta T2, but it's
well, you can pick one
Yeah.
variable here.
it'll be the same.
So this T2 and this T2 is the same T2.
And that's
So you have, so and this ratio equals to 0.43, and this ratio is equal to 1.25. Any ideas? What could we try to do now?
Well, it's definitely like wrong, but like because it's like well, it's not the same equation. I'm not sure how.
It's not the same equation, yeah. Those are two different equations, but
Yes.
why would it be wrong? We did everything right.
Well, no, I was gonna say like because this over this is 0.43, so I'm not sure how to like get or like relate the 0.43 to like this new equation with like L2 over T2.
So first,
Oh, I could.
I always recommend you start a new
Yeah.
step, a new chapter in your work. It's pure math. So just rewrite what you already have. Just don't see it anything else. So this is this. Now this 0.43 equals L2 G2. And you can, for now, forget about anything else and just try to figure out how can you approach this problem purely mathematically, because that's just mathematics.
We could set this equal to L2 over T2.
Well, that's a hypothesis. You don't know if it's right.
Yeah.
You don't know if it's wrong. So what do?
Try it.
You try it. Try it. If you got an idea, you should try it. And probably it should work eventually.
I always mess up algebra.
Yeah, but one thing is actual calculation. Second thing is an idea of that calculation. An idea. You have something like that. X plus y equals 5, and 2x plus, I don't know, 10y equals 120. I don't know. Could you find x and y if you had to solve these two equations? What would you do?
I would.
Substitution.
Yeah, and you would have to get just x plus y alone, so you could make that 5.
So that's exactly what you're supposed to do, because the idea doesn't depend on what letters we use or what kind of problem we solve. The idea is the same. We have to kind of get rid of unknowns eventually, use substitution method. And if I remember correctly, in the past, the first thing what people done is get rid of all fractions, just cross multiply everything, because when you see, simple straight equations, it's just easier to see what could be the next step. So that's probably the first action right now to do. Just cross multiply, just simplify, and then just see where it leads you. Yes?
Do we have lab today?
Yes?
And, well, my schedule says
It's supposed to be at 11 in room 134.
thank you.
So that person was at least late to the lecture. Because otherwise she would know. All right, so just go ahead. You can use all this paper. So this times this,
I just cross multiplied and then.
yeah, equal this, and you can simplify this. A fraction bar always makes math harder, so it's always easier to get rid of the fraction bar.
I'm just gonna get rid of the negative factor.
Okay. Okay. That's a very good kind of intuition. Just make things as simple as possible. If you can make it simpler, make it simpler. Yeah. So far, you're just working on this, but you didn't use this. You have to use both at some point. So you kind of have to follow both paths. And so
I'm just because you can't just because if I divide all
again,
this by
you're
2,
trying to think. That's what's wrong with what you're doing. You need to do just right.
Yeah.
You get an idea, write it down. You shouldn't be afraid of writing things down. And you have to use this equation. And you didn't. And the first thing to do about this equation, make it simpler. Get rid of the fraction bar. So just rewrite this equation without the fraction bar.
I did that
Where?
right here.
No, that's the first equation.
Oh, sorry. Oh, this without. Okay.
Yep. Now that's not a t. You cannot just change the variable. Okay. Much better. Now, see, this L2 and this L2 supposed to be the same L2, correct?
Oh, yeah. So then.
So if it's the same, what can you do?
Set them equal to each other. So that would be plus and then minus T2 1.25 equals L2. And then this is also equal. Oh, crazy. Minus T2.
Let's hope we haven't done any silly mistake somewhere, because if we made a mistake, we would have to start from scratch and check every step. But so far, I think everything looks good.
And then just divide both sides by.
Let me check. I forgot what I was looking for in the end.
Meters.
We need to calculate S, basically.
So once we find the T2, because we have T1 already, then we can find
Oh, you can use this to find that. Okay.
3, 2, 5, 8, 8. So 1939.39. Okay, so now that we have T2, I think what we want to do.
That's your. That's L2. That's this. But if you know this, then you can find that. Okay.
Because I think what it was asking was
Yes.
what L2 was, right?
No. Oh, really? Let me see.
How far east
How-
did you walk? So
Oh, yes. You're looking for L2. How far did you walk from this point to that point? Okay. Why? Why?
well, because I have
You have this. You have this. If you know T2, multiply
yeah.
by 0.43, and
I
that's
could
it.
do it like this too.
Yes,
That's just
of course,
making it more
of
complicated.
course. But why would you use something more complicated when you can use something simpler?
Just because. No, I didn't even. Okay, so that times that gave me. Okay, that makes a lot of sense. Thank you.
We have 6 trials, so
Yeah.
let's check this number. Let's hope we didn't make any mathematical mistakes somewhere, because strategy was used absolutely correctly. I don't see any reason why it wouldn't work.
Yeah, unless I did like some algebra wrong.
Yay!
Yay! Thank you. Okay.
And I'm sorry, but I think for now that's the only problems we can solve, because
Yeah.
I didn't have time today yet to start this topic.
Yeah.
This is what
Could do.
we will learn tomorrow.
Yeah, I could do this part because it's just the average velocity, but not
Well,
the next
yeah,
two.
but you don't have to.
Perfect. Thank you.
Sure. Did your number work, or you didn't finish yet?
I didn't finish yet.
Okay.
I did
Let's. Okay.
just. I got the right answer, but
Mhm.
I think it was just the wording. So when it says like north of east,
Okay.
That's
If you
easy.
scroll, there's supposed to be, scroll up. Supposed to be the note about this problem here. No, here. Problem 2, north of east means that the angle is measured from east direction toward north direction, counterclockwise. So this is how you should measure that angle.
so east towards.
Well, again, can you see your picture, please? Do you have a picture?
I have this picture.
No, that's not your
Okay.
picture. That's a computer's picture.
Oh my God.
You
It's
need your
right
picture.
Here, it's kind of light though. Pencil. So right here. So this was the angle that they wanted us to find.
East,
Ooh.
north.
I'm sorry, I have to
That's
catch a
okay.
bus.
Yeah. What's your path? You can A.
Here.
So this is your angle. Yes, this is your angle.
Yes. Oh no, they wanted us to find. I calculated this angle and it was the right answer. Which is what like kind of confused me, like this angle right here. Like,
You have one block over 3 blocks, right? So I want to check this angle, theta. Theta equals, so tangent theta equals 3 over 1. Theta equals inverse tangent of 3. And that gives us,
oh, this is late.
you can collect all the things, and I forgot, where's the tangent? Oh, here. Tangent. That's 71 degrees, right?
Yeah. And
And what's
so
your number?
You didn't use this.
What's your number?
It was that was the right answer. Where is it? 71.
71. So this is, I used exactly what I was told to use. This is east, this is north. I'm here, and my displacement points like this.
Yeah.
And my
but-
displacement has, well,
I guess my question is why the triangle would be that way and not, because like they walked up and then that way, so I kind of figured like this is the displacement, but you would want the,
well, because
it's the green line.
who cares? It doesn't matter. It's a start, it's a finish. This is your displacement. You can use this triangle, you can use this triangle. But the angle you are looking for has to be measured from east toward north up to the displacement. This is the angle. This is how you instructed to measure it.
From east.
This is the displacement. That direction due east, and from east you have to take a protractor and measure toward north. This angle belongs to this triangle or
'Cause it's east.
to
towards
that
north.
triangle.
Okay.
So the angle which has to be calculated is this, but that angle is equal to that angle in this triangle. So difference
Yeah, because when
mathematically.
it's this one, this is the 90 degrees, so then it's
Yes.
there or there. Okay. Yeah, because at first I calculated this because I was thinking like the one you did in class was like a straight line. It's like how far did you move?
Well, but that would be
Which one would that be?
that
this
would be
angle?
east of north, and you need north of east. See, it says north of east.
Yeah.
That means this direction. If it says east of north, so that means this.
Okay.
That's just how angles are described using
So right,
geography.
this would be east of north.
Yes. This is east of north, so starting from north toward east.
Okay.
And the east, so east of north, which means from north to east.
And this is
North of east
is
means
starting-
from east to north.
Okay. Yeah, the wording of it just kind of confused me.
Well,
I'm not a very spatial person.
that's why there's the note.
Yeah, I
It
didn't
says
even see that, but I still so east direction
Well,
toward north. So then
you
that
should
angle.
always check the notes because they help sometimes.
Yeah, definitely. Thank you.
Sure.
East of north. Okay. Thank you very much.
People doing lab.
Speaking of which, so was I supposed to go to lab yesterday? Because I had lab from 11 to 2:30.
It was just like the online.
I just wanted to make sure.
Test, yeah.
Okay. So like tomorrow, I have Tuesday and Thursday. I go in tomorrow, right?
Tomorrow you have to go.
Okay.
Starting today, everybody has to go into the assigned section.
Okay. I was freaking out about that yesterday.
Why? I thought my instructions.
Someone had told me differently, and then I started to doubt myself, even though
Yeah.
the syllabus and what you said was very clear.
That's it.
And then
Send
I
to
sent.
people. Thank you. Sorry, I don't want to be late for work. Thank you.
I solved it a while ago. I didn't have any questions. I just come in office hours to see if anybody else has questions. But thank you.
Okay.